Today's date is Tuesday, April 9th. Please put the date on your papers. April 9th, 2019. Your name and date are now on your papers. Let's talk about adding polynomials yet again. Because I need to be able to take it off if it ever gets broken, because things in here tend to break. Adding like terms with two variables. Yesterday was one variable, today it's two variables. So let's do some review. What are like terms? They're terms that have the same what and what. What are the two things? The only two things I'm looking for to make sure that they are like terms. I see India's hand. Who else has a hand? Ellery has her hand up. What are these two things? If you do not know, look back through your notes. This is a copy-paste of 14-1. What are the two things that like terms have in common? I see a total of only 3 hands, and this should be a review from yesterday. India, help us out.
Like terms have the same exponent and number or variable.
And the same, I'll use the word variable. Thank you. Variable. Or you could say the same power and the same letter, or whatever you want to say is saying the same thing. The power of the variable, the exponent of the variable, there they are. Those are the things you check over and over again to make sure that you can add them. And if they have those two, they are considered like terms because they are like each other. Thank you, India. And I should try to get marbles done at the same time so I don't have to do it at the very end. So India is in and marble is in. All right. And we are only allowed to add and subtract what things, Caroline? There it is, like terms. Please stop. All right, Caroline's marble is in, Caroline's XP is in. All right, so that is our review, and let's add some more to our notes. I'm going to add 5 terms under here, and you are going to have to circle the 2 that are like terms. So, x, 3x squared, negative y squared, positive y, negative 17x. Circle the 2 like terms. Which 2 are like each other? Do you see them? Which 2 are like each other? I should be able to walk around and see people circling the 2 that are like each other. Some people are still thinking about it and haven't circled. All right, Jaden, which 2 were the like terms? Which 2 did you circle?
What?
Which 2 did you circle for like terms?
I circled the x's.
The x's like this and this?
Yeah.
You are correct. Those are the like terms because they are both the same letter, the same variable, x and x, and they're both the same power of 1. Sorry, what was that?
Okay.
You may now turn in your participation card. Yep. You can definitely turn it in, and you get a marble. All right, so, and here is our little guide. Whenever you are adding and subtracting, the what never changes. You're only adding and subtracting what. And this is using the vocab that we learned yesterday, a little bit of review. What never changes. For example, if I added these 2 together, I would get negative 16x. What did not change when I was combining those like terms? And what did I actually add? I'm looking for some really key vocab terms for this one. This one is pretty straightforward. Only one person knows, 2 people know. Only 2 people, 3 people, 2 with cards. Ellery. The variable never changes. The variable and the power, I guess. So we'll add 2 things. The variable and the power. Both of those things never change. And then, Ellery, you add or subtract the
Coefficient.
Coefficient. There it is. My 3D printer was $750. The new model, that's way better than my version, is $750.
Can you sell the old one and get the new one?
I can sell the old one for approximately $200.
Oh, you lost it.
I got wear and tear because I had to replace parts. Parts are cracked.
You just keep it. Yeah, something basketball.
Yeah.
When I was looking
Yeah, you might as well just keep it.
Yeah, I just need you guys to buy me another one. Maybe with funding next year, we'll see. Okay, so the coefficients are the things that you add. If you don't have one for this example, this is a 1 in front of the x. So that's why I did 1 minus 17 is negative 16. That x never changes. That will start confusing us tomorrow, because tomorrow the power will start changing. So knowing when the power does and does not change will mess us up. All right, so coming down to here to example 1. I need to simplify this. And it's just kind of a review from yesterday again, putting our little toe in the water before we jump into the pool of mathematics. Who can do example 1 for me? Who can combine like terms? I see 1 hand, 2 hands. Again, raise your hand with a card so I know to give you preference. I see a total of 3 hands, Beverly, Ellery, and Anna. No one remember this from last year? Okay, there we go. We got Colby, Martine. Anna, you've been very patient. I'll go with you.
Okay, so add the like or combine the like terms, so 2x squared and minus 4x squared.
Okay, that combines to form.
And then I think that's negative 2x squared.
It is indeed negative 2x squared. And then
3y squared plus 2y squared, so that'd be 5y squared.
it would indeed be a positive 5y squared. Yeah, thank you. You can turn in your card. And that is our final answer, so we will box it. Thank you, Anna. 50 XP and our marble.
You didn't have to change the negative because you didn't have parentheses.
Yeah, so there were no parentheses. They were already dropped, so I was straight on just doing 2 minus 4. 2 minus 4 is negative 2. You always take the sign with the coefficient. That number, or this negative sign, is attached to that 4. I consider this a coefficient of negative 4. Or you can think of it as subtracting a 4. I guess either way is fine. Yeah, did that answer the question? Perfect. All right. Give me a fist of 5. How well are you following so far? Leo's holding up his phone because he's following with his phone. Fist of 5. Really well. Okay, thank you. Example 2. This one is going to be a little bit harder, but now I have multiple letters. That means I need to check each letter. I have an A and a B. Both of them are to the power of 1. That means like terms will also have an A, also have a B to the power of 1. Who wants to take a shot at example 2? It's a little bit harder, but I think you guys got it. I see Beverly with her card raised with a hand. Who else wants to try this one? Ellery with no card, but I have a good backup. Who else wants to try example 2? I see Anna with a raised hand. I see Lorea. All right, Beverly, help us out. So negative 3ab, so you have this ab right here, this ab right here, so there's a 1 and a negative 4 to get a negative 3ab. Okay, so far so good? Minus 3a squared, and that came from right here. And then finally, I'm going to underline the next one, plus 2b squared. You are correct. We didn't have to worry about distributing a negative. We just had a positive, which meant we were allowed to immediately drop the parentheses and then just add like terms. The tricky bit is AB and AB were our like terms. Everything else cannot be added. That is our final answer. Anna.
Could you put negative 3a squared with one of the ab's and drop the a or something like that?
You could if you were manipulating an equation, but in this case, since you have no equal sign, you can't really do anything. Yeah, but that's a good strategy to try to combine terms. Unfortunately, you can't do anything in this case. Yeah, they're totally separate. Even though it contains that letter, even though this B and A are in A and B, they are considered like or unlike terms, I guess. All right. Example 3. Who wants to give it a shot? And I forgot to come back here and give Beverly her XP. Or did I? I forgot. Yep. So Beverly, there's your XP, 50, and marble. Example 3. Who wants to give it a shot? It's a lot harder. I see Beverly's hand, Ellery's hand. There's a lot more that you have to do here. Sam with their hand. Anyone else? All right, Sam, go for it. Okay, make it a plus. Negative, okay. Turn that into a subtraction. So scribble that one out and make it a minus sign. Okay, yeah. So you distributed the negative. Perfect. Did you want to do another step or are you good? All right, thank you. So Sam is in. Please stop, Oscar. All right, so Sam did the first step for us, which is super important. That was the most common error on the test, distributing the negative. What do I do next? Quiet raise hand. Lorea, help us out. So 4xy squared and 3xy squared. Yep. And then what do I get when I combine those two? You do indeed get 7xy squared. Perfect. Did you want to do another step or are you good? All right, thank you. So Lorea, you are in. Your card has now been turned in. And Marble is in. All right, I need someone else to identify the next step. No new hands. I'm looking for cards. I want to try to get as many cards in as possible. If every single person gets their card in, I will give everyone 200 XP. Colby, go for it. Okay. Ellery, go for it.
So I would take 6x squared y plus or minus x squared y, which is going to give you 7x squared y squared? Or would it be like...
So the variables won't change. I'm just going to copy down this x squared y part. So x squared y. Okay, now you tell me the coefficient.
It would be 7, right? Because, well, no, okay, it would be 6 still, but you have 2x squared now. So would it be...
So you should kind of think about this as one block. So this is a block and this is a block. I have 6 blocks and I'm subtracting 1 block.
Okay,
so how many of these blocks do I have?
It would be 5.
It would indeed, yeah, be 5.
I was adding, that was my problem.
There it is. And it is a positive
And
5.
then you just leave the y as is.
Yeah, exactly. Yeah, so you don't touch the variables.
1, right? Okay.
Yeah, the variables don't change. If you see x squared y, copy down an x squared y because up here we said the variable and the power do not change. They never, never, never change. But the thing that does change is the coefficient. This had a coefficient of 6, a coefficient of negative 1. 6 minus 1 gives us 5.
Then can you break apart the terms? Could I take the 5x squared part and leave y by itself to combine with a different term? Or are they...
You can't break it apart because they're being multiplied.
Okay.
Yeah, not unless something special is happening, which we probably won't ever hit until next year. For now, they don't fall apart. They stay together. All right, so Ellery did a great job. I always forget if I gave XP. I did not. So Ellery, you got another 50 XP and another marble. Who can do the next step for us? Anna, go for it.
So then you just keep the negative 3x squared plus negative, or minus 2y squared.
Yeah, so you're seeing, I'll do a squiggly line underneath this one. This will be a negative 3x squared, and we can't do anything with this one either, so I'll do maybe a cloud around this one to make this a different term, and that's going to be minus 2y. Yep. Thank you, Anna. Those two cannot be combined with anything. They were by themselves, and that is our final answer, so I'm going to box that. Yes?
How does this relate to geometry?
It doesn't. This is stuff that is missing in Algebra 1. We didn't have enough time to finish in Algebra 1, and I want to make sure that you guys aren't behind for Algebra 2. And in fact, that's such a good question. I'm going to give you XP and talk more about why I'm doing that. So, in general, we are right, not here, we are right here. We are on Unit 14. I am teaching you guys polynomials because that's the last half of Algebra 1. Right now, Algebra 1 is doing the exact same thing. Then we're going to hit Unit 15, which is another just 1 week. Both Unit 14 and Unit 15 are being taught as a way to get you to the huge unit that we did not get to in Algebra 1, quadratics. And you might be thinking, wait, quadratics sounds familiar because last time we learned about quadratics where I said quadratics was whenever we have a degree 2 term, x squared or 3x squared. These are the things that we're supposed to study in Algebra 1 that we didn't get time to study. Generally, these make U shapes and upside down U shapes. I want to study them, but in order to study them, you first need to know how to manipulate quadratics, which is a subcategory of polynomials. So this whole week, I'm teaching you how to add and subtract and multiply. Next week, I'm going to teach you how to undo multiplication, how to factor. And then the week after that, we're finally going to hit quadratics. Yeah, thank you, Martine. I hope everyone is now on the same page. And I'm looking at our unit guide. Looks like one person has been updating their unit guide. Thank you, India. All right, so coming back here and coming back here. All right, so just a little bit more for our notes. Degree with multiple variables. We're on the back side now. All right, so I need a quiet raised hand to help me out here. To find the degree of a term with multiple variables, what do I do? And actually, I don't think anyone has seen this before, so I'm gonna give this one to us. I'm going to add the exponents. For example, this polynomial right here, this term, it has 3 different variables, 3 different letters, x, y, and z. X is to the power of 2, y is to the power of an invisible 1, and z is to the power of 4. So to figure out what degree this thing is, I literally just add these top numbers, these powers. 2 plus 1 plus 4. Well, 2 plus 1 is 3, 3 plus 4 is 7. This is a degree 7 term. All right, and this is stuff that I'm not going to be testing you on, but it is going to be part of Algebra 2. I figured I might as well prep you guys. I highly recommend you writing your answers out in standard form. So this is the way that mathematicians often write polynomials, and it's called standard form. It's when you first write the highest degree term. So this is where the term with the highest degree or the biggest power, so I'm going to say highest degree, is written first, followed by the terms with the next highest degree. We are approximately 60 seconds away from finishing our notes, and then you have to do your summary, but we're really close to finishing. We have this example 4, which goes really, really quick. I need some volunteer. We're going to do 1, 2, 3, 4, 5 quick volunteers to tell me what each of these degrees is. What degree is y? What degree is 3x squared y? What degree is 17y squared? Each of these is a separate volunteer. Tons of XP, tons of chances to get your card in. All right, first volunteer. What degree is y? Y is to the power of what? Quiet raised hand. Quiet raised hand. I still only see 2 volunteers. 3 volunteers. Beverly, go for it. Say again?
Power of 1.
Power of 1. So it's linear. Yeah, I'm just going to write the power down here, the degree. So this is going to be a degree. Thank you. This is a degree 1 term. Write it underneath. Y is a degree 1 term. So thank you, Beverly. Tons of marbles here. Tons of XP. This 3x squared y term, I just add, as I said up here, I add all the exponents together. This is a degree what term? Quiet raised hand. Colby. 3 term. Thank you, Colby. And marble. Next one is a degree what term? Martine. Careful. Just look for the power. 2, yes. It's a degree 2 term. Thank you. All right, Martine, you are in. And XP has been given. All right, next one is a degree what term? Someone that still has a card, please, please. All right, Sam. Ooh, careful. This is a degree 1 right there. So 1 plus 2 is, there it is. Yeah, degree 3 term. Thank you, Sam. And finally, a degree what term? Oscar. Degree 4 term. Thank you, Oscar. All right, now, in order to write this in standard form, I write it from greatest to least. The greatest degree is this one, so I'm going to rewrite x to the power 4. The next greatest degree, well, I have 2 degree 3's. It doesn't matter the order. I can now write either this term or this term. Both are fine. So I'm just going to do minus 3x squared y minus 8xy squared. It didn't matter which degree we did. We went 4, 3, 3, then I'm going to go 2, 1. 2 is going to be 17y squared, and then 1 is going to be y. This was 2, then 1. So that's how you write it in standard form. I highly appreciate when you write it in standard form because it's really easy for me to see what's going on. Yeah, India.
If you have 2 terms of the same degree, how do you determine which one goes first?
It's random. I would say the majority of mathematicians, actually, you can't even, I mean, generally it's alphabetical order, but it's when it's a case like this, it doesn't matter. They're both the same degree. Yeah, you just gotta randomly do it. Yeah, other questions? All right, please write your summaries now.